am Almira Ambrioso, and now I would like to discuss to you my topic. It is all about inductive reasoning. But before we start, I would like to share to you the four contents of my presentation. So the first one is definition. So later on, you may know what are the meaning of inductive reasoning, what are the characteristics of inductive reasoning, and what are the examples of inductive reasoning. And later on, you may know the conclusion of my presentation. So first, what is inductive reasoning? So, when we say inductive reasoning, it is a method of drawing conclusions by going from the specific to the general. It is also a method of reasoning in which broad generalization or principles. Inductive reasoning, it is a logical process based on experiences, observations, and facts to evaluate a situation and make a general assumption like a theory. In short, inductive reasoning typically involves applying something that is true in one scenario and then applying it to other scenarios, and that is inductive reasoning. So, what is reasoning in math? So, reasoning is an important aspect of solving mathematical problems. Essentially, reasoning is a process of combining logic and evidence to draw conclusions. Mathematicians reason by applying rules, prior knowledge, algorithms, and assumptions to help them solve problems. So there are two reasoning in mathematics, the inductive reasoning and deductive reasoning. But our topic today is all about inductive reasoning. And now, let's proceed to the characteristic of inductive reasoning. So these are the three characteristics of inductive reasoning: the generalizations, probabilistic, and based on evidence. So in short, it is a bottom-up approach where specific instances or examples are analyzed to derive broader generalizations or theories. In inductive reasoning, the conclusions are probabilistic rather than specific, as they are based on patterns and trends observed in the available evidence. So, in short, in inductive reasoning, it uses specific pieces of evidence to draw conclusions that are probably but not necessarily true. Let's proceed to the example of inductive reasoning. So our first example is 4, 8, 12, 16, and let's predict the next number. So let's encircle that one. So let's make a pattern. The step 1 is make a pattern. So the first number is 4, so we will use that number 4 to add 4. 4 plus 4 is 8. So let's use again the number 4. 8 plus 4 is equal to 12. And then next, number 12. So 12 plus 4 is 16. So same situation. So 16 plus 4 is it gonna be 20. So that is the next number of 16. So 4, 8, 12, 16, 20. So the next example is 1, 6, 16, 31, 51. And let's predict the next number. So the pattern is, let's find the difference. So the difference between 1 and 6 is 5. 6 and 16 is 10. 16 and 31 is 15. 31 and 51 is 20. So 5, 10, 15, 20. So the next number for 20 is 25. So 51 plus 25 is 76. So 76 is the next number of 51. The last example is 10, 20, 30, 40. And the pattern of this is, let's find the difference of 10, 20, 30, 40. And the difference between the number is 10. So let's add the 40 into 10 to find the next number, and it will be 50. And now we know the answer. So for the number 1, the 4, 8, 12, 16. And the pattern of this is 4. So the next number of 16 is 20. For the number 2, 1, 6, 16, 31, 15. The next number for 51 is 76 because the pattern of 1, 6, 16, 31, 51 is the difference between the number. And for the last number is 10, 20, 30, 40. The pattern of this is the difference between the number and it is 10. So the next number for the 40 is 50. And now, let's proceed to the conclusion of my presentation. I hope that you have learned something from my discussion this morning. And thank you for listening.